Hello, ladies and gents, and happy Friday. Today is going to be a little bit different than other notes we have done. First and foremost, we are not really going to do anything new. There's going to be like a tiny, itty bitty teeny part that is new, but it'll be super, super, super easy, I promise. Second, we are not working out of the worksheet, as you can tell. Or we're not working out of the workbook, excuse me. There's a worksheet for today. If you don't have a printer, totally okay. I don't either. Just grab a piece of paper. You can write on that piece of paper. Just open that worksheet so you can follow along. Also, as you can tell here in step 4, homework is going to be announced in the video. If you don't hear what it is, you are going to have to watch it again. So I'm going to make sure you can watch and pay attention. So it's going to be announced in the video. You don't hear the homework, watch it again. I don't want to see any emails that say, Mrs. P, what was the homework again? If the email is, hey, Mrs. P, this is what I understand the homework to be. Am I correct? That's okay. Now, since today is not going to be out of the workbook, it is going to be really a review of everything we have talked about in this Unit 8 during this e-learning period. It would be really beneficial for you to open up this cheat sheet. Unit 8, whoops, that totally is going to go to the wrong place. I'm going to go back. It'd be beneficial for you to open up that Unit 8 cheat sheet all the way at the bottom. Everything is summarized there. I am not going to flip back and forth to go to the cheat sheet, but I promise you that everything I say is there. We are going to be talking about a lot of this. I will talk about transformations, parts of a parabola. We're not going to do an application today, but we are going to solve by square roots, the quadratic formula, the discriminant. I will use some terminology that's up here. We will do some multiplying, combining like terms. It's all going to be in there. So refer to this cheat sheet. This is everything we have talked about so far. So without further ado, here we go. We're going to flip this guy around. And oops, put that camera on backwards. Here we go. So our first equation is x squared minus 4 equals 0. As you can tell, scanning through the worksheet, we're going to find the discriminant, we're going to factor, we're going to use the quadratic formula, we're going to solve using square roots, and we are going to graph. So in order to do a lot of this, it's really helpful to identify our A, B, and C values. So we know A is the number in front of x squared. I see nothing in front of x squared, so A is 1. X squared exists, so it's not 0, it's 1. Now, B is typically the number in front of X. And if you notice, we have no B term. No B term. So thinking about saying the word no B term really means B is 0 and doesn't exist. And C is our constant, the number that stands alone. Pay really close attention. There's a negative in front. So C is -4. Okay, so first thing we're going to do, we are going to find the discriminant. Again, if you forget what some of these things are, go back to that cheat sheet. The discriminant is this formula, b squared minus 4ac, and the discriminant is what tells us how many solutions are we going to have. Is it worth it for us to even spend time doing the quadratic formula? That's what the piece that it's usually tied the closest to. So I'm going to plug in my numbers. B is 0, parentheses are key here, minus 4 times A, which is 1, times C, which is -4. I'm then going to go to my calculator and I'm going to type in everything I see from left to right, parentheses and all. Double checking that I have everything correct. Looks good. Our discriminant is 16. So what does a discriminant of 16 mean? Again, anytime you're unsure, pause it, go to that cheat sheet. A positive discriminant, and 16 is a positive number. A positive discriminant means we are going to have 2 solutions. When we solve this equation, we should get 2 answers. Remember, the discriminant is what's under the square root in the quadratic formula. I can square root a positive number, so I know I'm going to have 2 solutions. And keep in mind, graphically, another name for solutions is x-intercepts or zeros, and we will look at that connection later on. Okay, now that we found the discriminant, I'm actually going to go a little bit out of order. I'm going to go down here to the quadratic formula. If you remember when we did the quadratic formula, I actually sang it to you. If you know Pop Goes the Weasel. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. The quadratic formula is a method for us to solve an equation, to answer the question, what does x need to be in order for me to ultimately get 0? Well, solving with a squared is much more difficult than in a lot of cases than solving without an exponent. So the quadratic formula, as ridiculous as it looks, is actually a pretty straightforward way for us to solve. So I'm simply going to plug in my a, b, and c. I need the opposite of b. Well, our b is 0, and the opposite of 0 is just 0, so we leave it. Plus or minus the square root of our, oh wait, this is our discriminant. Discriminant. Spelling is not my strong suit, so I got to sound it out. And we already figured out our discriminant way at the top. Our discriminant was 16, so I'm not going to calculate this again. I'm just going to put a 16 under my square root. All over 2 times a, which was 1. Okay, we're going to simplify further. The square root of 16, that's a perfect square, is 4. And 2 times 1 is 2. Now we know we can't both add and subtract at the same time, so here's where we split. One time, which I add 4 and divide by 2. One time, which I subtract 4 and divide by 2. Well, 0, adding it does nothing. Subtracting from 0 does nothing, really. So 0 plus 4 is 4. Divided by 2 is positive 2. And 0 minus 4 is negative 4. Divided by 2 is negative 2. Our two solutions, we knew we were going to get 2. The discriminant told us we were going to get 2. Our positive 2 and negative 2. Now, in this case, we could actually also solve using square roots. Now, there's no formula for using square roots. I'm just going to rewrite my original equation, x squared minus 4. And again, this is in the cheat sheet if you want to see this in action. The reason we can solve this one using square roots is because b is 0. We technically have no b term. Having no b term means, yeah, we can use the quadratic formula. We just saw that. But having no b term means we actually have a more straightforward and quicker way to get to our answer. In order to solve using square roots, we're going to try and get x by itself. So first thing I'm going to do is add 4. Whatever I do to one side, I do to the other. So we have x squared equals 4. We need to get x by itself, so we're going to do the opposite of squaring, which is square rooting. Opposites cancel, leaving us with x. And we know whatever we do to one side, we do to the other, and we know the square root of 4 is 2. Keep in mind, though, and this is the only difficult part about square roots, we have to remember we have both a positive and a negative, that plus or minus sign. You could also write it as 2 and negative 2, where x equals 2 and x equals negative 2. We get 2 solutions anytime we square root. Now notice, same 2 solutions we got from the quadratic formula. It doesn't matter which solving option you choose, you will always get the same answer. Now, the cool part is, and this is going to be where the little teeny tiny bit of new stuff comes in, is that factoring is very much tied to this. So I'm going to rewrite my equation again. And this time for factoring, I'm going to insert a 0x. We have no b term. I'm going to insert that in here. It's going to help me out again. Now, we know factoring, I can either do the list method or I can do the x method. I'm going to choose to do the x method this time, kind of just your preference. So here we go. I need 2 numbers that multiply to give me negative 4x squared, and 2 numbers that add to give me 0x. X method is, like I said, it's preference, but X method I think is great for people who can kind of think about the factors, the pairs that multiply to give me negative 4x squared, can think about those in their head. In this case, we're going to need 2 and 2. My only other option is 4 and 1. But in order for me to add to nothing, I need a pair of opposites. And don't forget that x after. So I need a negative 2x times 2x is negative 4x squared. And negative 2x plus 2x is 0. Okay, now that I have my chosen 2, I'm going to do my backwards box. And in my backwards box, I am going to put my x squared in the top left, my constant term in negative 4 in the bottom right, and then my 2 chosen terms right here in any order in the empty squares. And then working out and up, I'm going to identify my greatest common factor, my GCF. X squared and 2x have x in common. Negative 2x and negative 4 not only have a negative in common, they have a 2 in common. X squared and negative 2x have an x in common. And 2x and negative 4 have a 2 in common. That means the factors, the pair of binomials that multiplied to give us this original problem must have been x plus 2 from the top and x minus 2 from the side. Now, so far, there's nothing new. Here's the very, very tiny new part. Notice that equals 0 we had in our original equation. Equals anything is really indicating solving. Now, we've already solved and found solved by quadratic formula, got 2 and negative 2. Solved by square roots, got 2 and negative 2. The cool part is factoring actually solves for us as well. If you want to do square roots and it works for that problem, do it. You want to do the quadratic formula because it works for any quadratic equation, do it. You want to factor, do it. Here's how factoring works, and you might already notice the 2 and negative 2, but here's where they really come from. I'm going to look at one factor at the time, and I'm going to answer the question, what number minus 2 gives me 0? Or simply I could solve by adding 2 to both sides. Well, positive 2 minus 2 would give me 0. I'm going to do something similar with this equation. What number plus 2 gives me 0? Or I could simply solve by subtracting 2 from both sides. Well, negative 2 plus 2 would give me 0. Just like I got with the quadratic formula and with square roots, I have 2 and negative 2. All of these are so very related. Now, as we remember, the graph is also really related. Now, this happens to be one where if I remember transformations, I don't need to go to my calculator to graph. I don't have an a term really. I have a 1. It's positive, which tells me my parabola is going to open up. I have no parentheses. Inside parentheses is the h, which tells me left or right. But I do have a k, a minus 4, which tells me I'm going up and down. A minus 4 after the x squared tells me my vertex has shifted down 4 units. So I'm just making 4 little tick marks. I'm going to put my vertex there. And if you remember, I also, if there's no change in A, I had told you that that just means your next points are up 1 over 1 in either direction. So I'm going to just kind of randomly put those in there. And I'm going to draw my picture. Now, again, like I said, if you remember, it's not a really great U, but we'll go with it. If you remember your transformations, that's great. You could also go to your calculator and simply type in your x squared minus 4 and hit graph. And hey, look, our vertex went down 4. Our vertex is at the point 0 over, 4 up. And take a look at those x-intercepts. Take a look at where we cross the x-axis. I'm just going to go to 1 because it takes a while for me to tap my arrow over there. Notice what number it is. It's 2. If I look at the other side, it is negative 2. Our x-intercepts are at 2 and negative 2. And that we remember because our x-intercepts are the same thing as our solutions. Our x-intercepts are 2, 0, and negative 2, 0. My graph where I cross the x-axis is the exact same thing we get when we solve by factoring, when we solve using the quadratic formula, or when we solve using square roots. It's a lot that we have learned, but it's all connected. So bear with me, I'm going to go through another example here. Our second example of x squared minus 6x plus 9. And you'll notice the prompts are pretty much the same. So I'm going to start by identifying my a, which is 1, my b, which is negative 6, and my c, which is 9. First thing, we're going to go to that discriminant b squared minus 4ac. I'd encourage you at any point, pause the video, see if you can do it yourself, and then watch and verify with me. Okay, plugging in parentheses. Parentheses are key. Our b is negative 6. Our a is 1. Our c is 9. I'm going to go to my calculator. Typing in everything exactly as we see on our paper, parentheses and all, double checking that it's correct. Hit enter, we get a discriminant of 0. Okay, what the heck does a discriminant of 0 mean? Go back to that cheat sheet on Canvas if you need it. Well, a discriminant of 0 means we have one solution or one x-intercept. A discriminant of 0 means, yeah, keep going with solving with the quadratic formula if you need to. We're going to have one x-intercept. So just like last time, I'm actually going to bounce down to the quadratic formula because the discriminant and the quadratic formula are so related. I'm going to put those in order. And I'm going to rewrite my quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. I can sing faster than I can write there. Okay, I identified my a, b, and c up at the top, so I'm going to plug in. Here we go. Opposite of b would be positive 6. Our b is already already negative, excuse me. So that's why I don't like, if you remember saying negative b, I say opposite of b, because if it's already negative, I actually need to flip that sign. Plus or minus the square root. Oh, wait, there's the discriminant. We already found the discriminant. It's 0, so I'm just going to plug in a 0. All over 2 times a, which is 1. Okay, go ahead and simplify. We have 6 plus or minus, well, the square root of 0. Oh, that's just 0 over 2 times 1, which is 2. Can't add and subtract at the same time, so we're going to split into 2. One where we add 0 and divide by 2. One where we subtract 0 and divide by 2. So 6 plus 0 is 6. Divided by 2 is 3. 6 minus 0 is still 6. Divided by 2 is 3. Remember that discriminant told us you're going to get one solution. Visibly, it looks like we have 2, but compare them. They're exactly the same thing. We did only get one solution. It's 3. It popped up twice, but we still only got one unique solution of 3. Now you'll notice what's missing down here. There's no option for solving by the quadratic formula. Why is that? Or no option, of solving by square roots. We did just do the quadratic formula. No option of square roots. And that is because we have a b term. If you go back and look at that cheat sheet, it says square roots is only an option when your b is 0. When you have a b other than 0, square roots are not going to work. Square roots are great. They're a great shortcut really for solving if you can use them, but square roots do not work all the time. Quadratic formula works all the time. Factoring works most of the time. Square roots only work when b is 0. We have a b. Square roots are not going to work, which is why it's not an option. However, factoring is an option. So I am going to rewrite this down here, my equation down here. I think it's easier to factor while we are looking at our equation. And this time I'm going to do the list method for factoring. So here we go. I need, because I did x last time, right? Where is yes, last time I did the x. Okay, so here we go. I need a pair of numbers that multiply to give us 9x squared. So factors of 9. I got 1x times 9x gives me 9x squared. 2 is not going to work. 3x times 3x gives me 9x squared. 4, 5, 6, not going to work. At the same time, I need a pair that add to negative 6x. Well, comparing these two pairs of factors, the only one that I'm possibly going to get that negative 6x out of is the 3x and the other 3x. But I need a negative 6. Well, if I only make one of them negative, adding would actually cancel them out, then they're opposites. I need them both to be negative. And having them both negative, a negative times a negative is still a positive. So both of those 3x's are going to be negative. Now that I've identified my needed terms, I'm going to go to my box and I'm going to fill in with the x squared, my little rainbow terms up here, top left and bottom right. and our new two chosen terms, and since they're the same, it really doesn't matter what order they are, in the other two boxes. Now I'm going to look for GCF moving up and out. X squared, negative 3x, have an x in common. I'm going to go up and down now. X squared, 3x, negative 3x, have an x in common. Okay, slight little different thing here. Now, if I look, negative 3x and 9, they are not both negative. Now, I'm actually going to quickly take a look at the one we just did. If I look at this column, my not leading number, but my second term was negative. I didn't worry about it. We have actually never, in this case, both the leading term and the final term were negative. I'm going to take out a negative. We have not yet had a case where the leading term is negative, but the following one is not. Here is a rule when it comes to factoring, and this is a rule that will always follow you. Never lead with a negative. Never lead with a negative. It doesn't matter if both terms are negative, doesn't matter if it's only the first term, but never lead with a negative. If the second term is negative, you can follow with a negative, but never lead with a negative. If it is negative, if the lead is negative, make it part of your GCF. So in this case, since I'm leading with a negative, I'm going to make it part of my GCF, and 3x and 9 are both divisible by 3. Looking at this column, again, I'm leading with a negative, don't like it, take it out. 3x and 9 divisible by 3. My factors are x minus 3 across the top and x minus 3 down the side. Kind of like that little, very much like the last problem we did, I'm going to throw this equals 0 on the end. We factored. We successfully figured out what multiplies together to get this trinomial, this problem that we started with. We figured it out. But as we realized in the last problem, factoring can also lead us to solutions. Now notice these factors are the same, so I really only need to focus on one of them. I need to answer the question, what number minus 3 gives me 0? Well, 3 minus 3 gives me 0. I could also get there by adding 3 to both sides of this equation to solve. Factoring gets us the exact same solution. Notice that the quadratic formula gave us. Exact same. If we could have done square roots, would have done the same thing as well, would have given us 3, but again, could not do square roots because of our B term. Factoring is great. It tells us what did we multiply to get our original problem, but we can take it a step further and also use it to solve. Now, the last piece that we need to do is get this graph. Now, you'll notice in this case, I'm not in vertex form. I don't have those parentheses that allow us to identify my up, down, left, right transformations. You might be thinking, well, the last problem didn't have parentheses either. No, but compare them. If I have a B term, all bets are off. When I have a B term, I can't easily identify my up, down, left, right transformations. When I have a B term, I can't use square roots. When you're in Algebra 2, you will learn how to go from this, which is called standard form, back to vertex, the transformation form, but we're not going to do that now. So what we are going to do instead is just go to our calculator, go to my y equals, clear out what we had, and I'm going to just graph using my graphing calculator. And when I graph, I notice, oh, look at where my vertex is. It is 3 over. Oh, wait, that should not be too much of a surprise because our discriminant had already told us that we are only going to have one solution. We already knew from solving that one solution was going to be at 3, so it makes sense that my vertex, the only part of my parabola that hits the x-axis, makes sense that it's at 3. I am going to go ahead and plot 2 more points to just kind of help me guide my parabola, my U-shape. And there is my parabola. My vertex, just adding in some special information about the parabola that we should know about, also happens to be my x-intercept, which is at 3, 0. I could, if I wanted to, identify my axis of symmetry. Now, the axis of symmetry is not a point, it's a line. It's a line that literally goes through 3. I could, if I wanted to talk about more key features, talk about how this vertex is a minimum. It is the lowest point on my graph, and it is at a minimum y value of 0. There's a lot you can talk about when it comes to parabolas. And as you move on in math, you will talk about these parabolas and more applications and the key features about them. Now, I realize we've covered a lot in our weeks in e-learning. It honestly is exactly what we would have covered if we had been in the classroom. The cool part is all of it is related. The discriminant, quadratic formula, factoring, square roots, graphing, all of it is related. Everything ties together in math. There's no one part about math that just really stands alone. So I think that is enough for tonight. It's tonight for me. It's daytime probably for you when you're watching this. But I told you I was going to tell you what your homework is while we are here online together. Ready for it? No homework. There is no homework. Now, don't stop this video yet. Just listen to what I have to say. There is no homework. Your only what you need to do is make sure that you are passing e-learning. If you're not sure if you are, look at Home Access Center. There's a column that says e-learning status. If it's a P, you're good to go. If it's an INC, incomplete, you need to talk to me. So check to make sure you're passing. If you are not passing, then work on that. That's what you need to do as your homework. Work on that. Any missing assignments, talk to me if you need to. Email me. My email is all over Canvas. Email me. Now, for those of you who are already passing and you're like, okay, now what? Well, take a look at your overall grade in Home Access. If your overall grade is something you're like, I want that to be a little higher. Maybe your overall grade is sitting at a C+. You want to bump it up to a B or whatever this situation happens to be. I have an extra credit opportunity for you. Your extra credit opportunity is to fully complete the third problem that is on this worksheet. The worksheet that we just did the first 2 problems, your extra credit opportunity, optional, but extra credit opportunity is to do the third problem, and you are going to email it to me. There's no submission link here. So if you opt to do the optional extra credit, complete the third problem on this linked worksheet, and you are going to email it to me. I want to make sure that everyone passes e-learning and this entire semester. So let me know if you have questions. Otherwise, get yourself caught up if you need to. Otherwise, no normal homework, just extra credit. Any questions, email me, and I will talk to you all later.